Hi. This is going to be week 3. Agent Forge, which is, in this case, a healthcare AI adversarial security evaluation platform that I've called Sentinel at this point. Um, it's for the clinical copilot healthcare AI sidecar that we built for OpenEMR. And it's running on Railway at the moment and targets the production sidecar URL that we have deployed. You're able to see right here. This system is able to tell you that the target is healthy, and the runner in this case is also healthy here. There's the last ran timestamp as well. So here it shows the test that is executed, the controls held, new findings that it had, and the risk areas. You can see here a mutations tab. We're going to go into that a little bit later, which is essentially the red team, which we're going to also get into, but it's the adversarial security threat platform. And the dashboard here intentionally does not render any personal health information bearing response bodies. So it's going to not show those things. We're able to reach the system here, the sidecar. We're able to hit it with this. And we focus on a few different seed cases here: data exfiltration, denial of service, identity exploitation, prompt injection, state corruption, tool misuse. So these cases are going to get run against the deployed platform to see if it was successful, failed, or it was uncertain. Uncertain means that while you did not actually succeed in getting the information you wanted or data exfiltration or whatnot, you ran into a case where, in this case, it failed because it was an expensive request. So it was not successful, but it was also not indicative of a successful defense. That means we have what I think is kind of the meat of the platform, where we have a red team, which is going to be essentially a set of agents that are going to coordinate attacks against the deployed platform of the sidecar. So you're able to see the different tests that run, and the mutations essentially take the evaluations here, different seed cases, data exfiltration, denial of service, and all these things, and then creates different mutations on them, essentially saying going from prompt injection 1 to like category specific escalation. So it'll have a seed attack and then mutate it to hopefully try to prompt inject or try to tweak it in some way that might make it more successful in attacking the system. And therefore, it's a much better representation of what an attacker might actually do. And it makes it a better view of what the security of the system that you have deployed is. We see here the mutations. We cover all 6 categories, and currently we have 0 new findings. Previously, we had findings like this. We have past recordings of a PHI dump. And as in the system, you want somebody to be able to review this information and then go make changes, which is what we've done. And therefore, in further runs, we did not have this issue. And this button would kick off the Brad mutation campaign, which does cost money. But you're able to see that these all come back as failures, which is what we want. I'm going to walk over the architecture slightly. We're using LangGraph to coordinate these different agents. Essentially, we have an orchestrator that's going to take these different cases and then trigger these campaigns. As I stated earlier, the red team agent is going to have 3 layers. It's going to have the mutation engine that takes the seed and mutates it into different templates. And then it'll have a strategy. In development, we are using a serverless 7DB fallback instead of the originally planned DeepSeek Distill dedicated endpoint, largely because of cost. We were able to get a large amount of the benefit of having a DeepSeek deployed system, but we're able to demonstrate more the architecture and the mutation system. We're able to mitigate some of the fall through prompting. But ideally in prod, we would use a dedicated and deployed system, LLM, that we could hit, that we fully own, and we know that is uncensored, largely because, and we didn't do this in this case because of cost, but if we were to flip the switch, if we were to deploy more resources into it, we definitely would. And we're accepting ongoing costs, fixed costs, we would definitely do the deployed version. And then there's the execution harness, which is actually going to do the HTTP requests and curl commands and Python scripts to try to attack the target system that you see here. There's a data layer here, which we're using Postgres for, which is going to have the evals and the eval results. There's going to be a regression harness, which is going to be remembering essentially where things were and where, based on new evals that we run, depending on the code changes made, if there's a regression, we're going to be writing that up with this documentation agent, which is going to write a report upon the security vulnerabilities or lack thereof. And which if it's critical, a human should get alerted and see this in the system that they should address this issue, as you saw earlier in the platform. Some other thing I wanted to highlight is that we do have this Langfuse system deployed for this case. We see the model costs. We're able to trace each of these runs and be able to see how long they take, how much it costs. And in this case, a lot of these are going to get unauthorized or something like this. And that's what you want. You want to be able to know that a lot of these cases are failing, and you want to know that they failed, but you're able to see how it is going through and trying these different injections and then see as well what they cost, which is good for observability. Thank you.